Good afternoon, everybody. I'm going to record a brief video today. Most of the work is in a Google Colab notebook, and you could actually just work through it. I will give you some assignments. The assignments are due next Thursday. That's to give you a chance to ask any questions that you need on Tuesday. Here we go. I'll start screen sharing. So I'm screen sharing, and you can see a Google Colab notebook or a Jupyter notebook, if you like, that is about Python programming and plotting. I will post this notebook to Blackboard, and all you would have to do is, if you've got a Colab folder already on your Google Drive, load it to it. If you don't, create a blank file in or a new file in Colaboratory and type a few things in it. It will create a notebook for you in your Google Drive, and just put your Jupyter notebooks in it. Anyway, so this is an intro to programming, and what I do is I start out giving you some history. We need to be able to plot, and I'm going to focus on plotting, but there's a history of Python. Since you'll find some Python 2 code on the web, I'm explaining the difference between Python 2 and Python 3 to you. I talk about programming. I talk about the basic modules that we're going to be using. And I talk about how when you have to do things, that's the way to learn how to do them. Then getting into the meat of today, you are used to dealing with variables that have single values. Much of the time we actually deal with arrays, but I'm going to begin with a list, which is essentially a 1-by-n array, and I can just do a simple plot using matplotlib and the a Python list variable. So I start out by creating a list, and then if I want to, and you can see I've defined a list here with the square variable, or sorry, square brackets. So if I run this program, it'll simply print the values of the list for me. Really, though, what I want to do is use a list variable to generate values for a plot. So I've imported, I'm going to import matplotlib pyplot as PLT. I'm going to define a list variable using using range, which will generate 100 variables for me, or 100 values from me, 0 up to 99. That's the way that the range function works. And I'm going to calculate a y value from it with just a square, and then I'm going to plot that. And then, having plotted it, I'm going to render the plot. And that's what the lines say. To illustrate something here, I'm going to actually, I see I've got a block that I didn't use. That'll be in EOS too, but don't worry about it. You just go to the next block. I've defined a range of 15, and then what I'm going to do is I'm going to calculate a list of y values from it, and then I'm going to print those y values. So here they are, and so you can see that. Indeed, although x ran from 0, although we said range 15, you can see that it runs up to 14, because 14 squared is equal to 196. But anyway, then I'm going to use that to do a plot, and here's the basic plot. So what we can do is here we can. I guess I should have run it, but let me run the plot, and you can see what the plot looks like, and then I explain what it does for you. But anyway, then I go through following it, the stuff that I just talked about. Then what I'm going to do is I'm going to introduce another variable z. You can say I've added it in this code block. And then I will plot both lines. And you might have noticed I've changed the range down to 10 in this one. The reason being, if it was 100, what would have happened is one of the plots would have been really small. And this enables me to get a decent plot for both the y and the z values. So I plot both of them separately, then I render the plot. So here it is, and you can see which plot is which. So we've got a quadratic plot and a cubic plot, and so you know the cubic function grows faster. So here it is. I could go on and add titles and labels and things like that, and I could actually choose these colors. I'm not going to. What I'm going to now do is I'm going to introduce NumPy, which we'll use more often. NumPy is a Python library, and where we use range to put variables in a list, we can use the function arrange to put the numbers or the values in an array, and I noticed that I've got I've actually got a misspelling there, which I'm going to fix because the function is arrange with one R. It's just array range, not two. When I actually used it, I spelled it correctly, but anyway. So that's what it is. So that's fixed, and the one I upload for you will be fixed. So then what I've done is I've taken a code block. I've imported NumPy as NP. I've imported matplotlib as plot again. I've generated what I'll call time data. It could have been, I could have called it anything else. I just decided I'll call it time for reasons that will be obvious later. And then I've used I've generated the array simply by taking values from 3 pi, from minus 3 pi up to 3 pi with a step of 0.01 between values. And in this, I could have chosen any other range. I just happened to choose this one, and I'm finding the amplitude, or it's probably really the height at each time. So I'll fix that column as well, that comment as well. We reserve the amplitude for the maximum height, but I named the variables correctly. And then what I've done is I've made a plot of it. I've added a title and shown you how to do that. I've shown you how to label axes. I've added a grid, and then in this group or in this piece of text here, I emphasize the X and Y axes, and then finally I'm going to render the plot. So if I run this, you'll see a nice plot of a sine wave, and there it is. It's what you're used to seeing. It turns out that there's a function called linspace that does the same thing. I've given you a link to its manual, actually much like I gave you a link to the arrange function in matplotlib. But anyway, here's the manual for linspace, and basically in this, instead of choosing the spacing between values, we choose the number of points, and I do everything else the same. So if I run this one, we get the same thing, but it's just two ways of doing the same thing. Also, you can change colors, and here's the symbols for the various colors. You can actually use more advanced colors here, and I provided a link to show you where to get the more advanced colors, but these will be enough for our purposes. Then I motivate why we are doing this. We're doing this because we're going to be dealing with continuous time signals, and the simple ones can be represented as sinusoidal functions. and we most often use cosines. So I've shown you the format of the signal we're going to use. We'll probably use omega instead of 2 pi f, but I use 2 pi f for now. And this one is defined from -infinity to +infinity, so it can't really exist because that would represent a monochromatic wave. But the universe, while large, it has not existed for an infinite amount of time. So it goes back a way and moves onward. But what that means is that any signal is actually going to have a range of frequencies in it, and we'll talk about that as we move through the class. But that gets us now down to what I want you to do, and most of the time for today will be spent with you doing things. So here is an assignment. I want you to produce a graph of a cosine, which I misspelled, and I will want it to extend not from -3 pi to 3 pi, but from -2 pi up to +2 pi. And then I want you to plot a sine curve on rendered on the same graph. And what I'll want you to do there is I'll want you to choose the colors of the curves. You can use the code fragments I've given you to guess how to choose the color. It's not very hard. You can just steal a piece and add it from where I show you how to color the names of the axes. But anyway. Then what I want you to do is to produce a tan function. And for this one, if you use -2 pi after 2 pi, you just get lines at the margins because the plot would be dominated by the large values. So you're going to have to pick a range between this to produce the typical textbook graph that you see of a tan function. And finally, what I want you to do is to go to a sine function and reduce the number of points on it. The easiest way to do that is using a linspace version of the function. But as you reduce the number of points, things will begin to happen to the plotted curve. And I want you to do that. And I want you to explain what happened, best done by doing multiple plots. Each of these will be worth 5 points each. And as I said, will be due next Thursday. And you can ask questions in the interim. But we'll be using these methods throughout the semester. So this was a good way to get you started. And the uploaded Python or Jupyter notebook will have the corrections fixed because I'll upload the version that I fixed as I did this. And you will also be able to run the things yourself, because I'm gonna zero out where the program had run before I upload it for you. But that's it for today. You will when you work through these things get all the class time that you should, because this is a learn by doing exercise, not a learn by watching one. So that's it for today. I'll see you on Tuesday. Have a good weekend. Bye. So signing off.